All right, now let's take a closer look at this motor controller. This giant heatsink here is one of the reasons why it can provide enough current to run these motors. Actually, it can run motors much bigger than these. The current limit is about 2 amps. We've already connected the motor wires directly to outputs A, B, C, and D. But now we need to control these, and we're going to use the control wires that are right here. We also have some wires up here, and they're tied together with jumpers. So just pull this off really quick so you can see what that looks like. Yeah, this is called a jumper, and it's just a little connecting device that ties these two pins together. I'm going to go reinstall that. Let's see what those pins are. I'm going to share my screen and then take a look at some pictures. So in this Google Doc, I've talked about these two different packages. So this is the one I'm showing you right now. And this is the H-Bridge right here, connected to a really big heatsink. This package has the control wires up front, and this package has the control wires sort of tucked behind the power bus. And they're labeled, the ones that are not tied together are labeled IN1, IN2, IN3, IN4. And that's what we're going to use to control the motor outputs. Now these two, I believe this says enable A and this says enable B, and the two inside ones are 5 volts. So what that does is it turns the enable A and enable B on, which is fine. In the other package, it's a little bit smaller. One of the things that the smaller package does not have is the on-off button, which you can see right here. That's a handy feature. But it still works the same. It also doesn't have the stepper motor controller, but it still does the job. So now let's go ahead and see how this is going to work with software. I'm using the online Arduino editor, and I can see I've set up some pin configurations. So left motor pin F, left motor pin B. I'm calling those forward and backward, and that's going to be a 9 and 10. Remember that you have to use the pins that are enabled with pulse width modulation in order to control this. And there are only 6 of them on an Uno, so that's going to tie things up. And then right motor to 6 and 5. Okay, so let's remember that. I'm going to stop sharing the screen and go back. All right, so left motor 9 and 10, and 6 and 5. All right, so we'll take a closer look. And on this particular board, this board is sold by my friend Terry, and they have breakout pins for each of the digital input and outputs, plus some extra pins that are up here to do some additional sensor control. So the pins go like this. We've got the blues are ground, the reds are positive 5 volts, and then the yellows are the control wires. So I could go, I have pins over here and pins over here, so I could go socket to wire this. But I think I'm just going to use some more traditional pins because most boards are wired like that. So remember, the digital input output, the digital I/O pins go from D0 to D7 on this first block, and then there's a gap. And then D8 out to pin 13. And then we have the other pins that are used for sensor addressing. So, right, so we want to use 9 and 10. Now when I picked out the wires, right, these are socket to pin. I got a socket here and a pin You can tell because they can marry together like that. And we said that, let me just double check here. So left motor is going to go to 9 and 10. All right, left motor, that's this one. And it's going to use these 2 pins right here. And so I'm just going to put a socket on there and then go to pin 9. So why 9 and not 10? Again, we're going to figure it out later on. So this is pin 7. On the other side of the gap is 8, and so this is 9. So in you go. And then when I'm picking out wire color choices, I try to get contrasting colors so I can tell them apart. So, oops, that's pin to pin. That's not going to work. Okay, so this is going to be the pin that controls output A and output B, and then that's going to go into 10. Okay, great. Let's see if we can't fold those over a little bit. Maybe I can tuck them underneath here. Okay, that's helpful. And then I need a couple more wires. So hold on. Pause and go get those. So I found some, this time I'm going to do socket to socket wires. And I was talking about colors before. So it's nice to have contrasting colors just so you can tell them apart. Because I think one of the things that's going to happen is I'm going to have to switch wires because the directions aren't going to come out right. Because this is all just kind of random. Like for instance, I'm going to go connect to this pin. And then my code says for right motor, I need to use pins 5 and 6. So when I connect to pin 5, and let's just verify what that's going to look like. So this is, and really while I'm changing things, I should disconnect power. That's the correct way to do it. So 0, 1, 2, 3, 4, 5, 6, 7. But I could have counted backward because I know this is always 7, 6, and 5. So then for pins, 0, 1, 2, 3, 4, 5, 6. So I'm going to connect into 6. All right, let's just make sure. 0, 1, 2, 3, 4, 5, and then 6. Okay, and contrasting colors, because I don't know if this configuration is gonna make this motor go forward or backward. I could fix it in software, but that's never a good thing. It's always better to fix it in hardware if you can. Because software, there's usually only one person who knows about the fix, and that's the person who wrote the code. But in hardware, it's a lot easier to see. Okay, so that's great. I've got these motors connected. And in terms of the software, what we're going to do is, in order to make the motor go in one direction, I'm going to write a low to one pin and high to the other pin. But I don't know if that's going to go forward or backward. So I need a test program to figure it out. All right, well, let's go ahead then, and I'm going to check some hardware out. And I'm going to connect the Arduino to a USB port so I can download some code. I'm going to share the screen again, and we'll go take a look at what the code looks like. So Great. Well, here we are. I'm using the Arduino web editor, which is kind of ubiquitous. It's nice because I'm doing it on a Mac right now. You can do it on a Chromebook. You can do it on a PC, of course. Okay, so let's see what's going to happen. So we have variables, and they're kind of long names, but they're very descriptive, which is helpful. So I've got left motor forward, right motor backward, and so on. And in void setup, we establish those pins as all being outputs. And then let's see what void loop looks like. Now in void loop, this is what's going to run over and over. Void setup only runs once. And I'm going to use the analog write command, which allows you to write a sort of percentage number to the Arduino pin. Usually these are digital I/O pins. So they're either going to be 0 or 1, or in terms of voltage, it's either 0 or 5. But I can access in between numbers by using a technique called pulse width modulation. And in the earlier part of this Google Doc, I show you how you can do pulse width modulation with an LED, because an LED is usually either on or off. But if you sort of blink it in different ways, you can make it appear to be dimmer or brighter. Looks like it's almost analog. And yeah, so that's a neat trick. I'll probably talk more about that in the next video. So I'm going to write a positive voltage to left motor pin forward, and then a 0 to left motor pin backward. That's on pins 6 and 5 respectively. And then the same thing on the right side. Did I mix those up? I think I did. Left motor pin forward, 180. Yeah, it's fine. So anyway, I'm just writing left motor pin first and then right motor pins. And then we'll do that for 2 seconds. And then we're going to shut them off for 2 seconds. So this will give us the opportunity to take a look at, are they actually going forward? So both motors should be going forward. All right, let's go ahead and upload this. Now my motor controller is off, so it's not gonna, I don't need to worry about this thing jumping off the desk or anything. All right, great, so done, everything's uploaded. Now we go back and take a look at our little robot. So I'm gonna unplug the Arduino because the program should be on there. The other thing I'm going to do is I'm gonna put the robot up on blocks. So I just have a box of screws here, and I'm gonna place it up like that. And so now the wheels aren't touching the base. And I'm gonna go ahead and plug the Arduino on. Now our code is gonna start writing right away. It's gonna start working. But because I have an on-off button, we don't have to worry about that. So I'm gonna go ahead and turn this on. So I see the left motor is turning, and nothing's happening on the right side yet. But of course, I did use slightly different style here. Now let's just check out if we're going forward. Yeah, we are going forward. So that's great. So we got those pins correct. 50-50 chance. All right, let's pause the video and see if I can troubleshoot. Okay, that was interesting. When I ran that code, it didn't work. And it was time to do a little troubleshooting. So I disconnected these wires, and I wanted to see if the motor was turning at all. And what I realized is that, well, for starters, you can actually just check the motors to see if they're working by just taking one of the wires, putting it inside the barrel coming off. This is coming off the battery pack, and then touching the other wire. Yeah, now it's running. But when I did this before, it was stuck. So what I did was I turned the board over, and I just grabbed onto the motor shaft. Oops, it's on a picture. And just grabbed onto like that and just gave it a turn. I think the gears were a little locked up. Okay, great. So back we go. So we're going to reconnect these wires again. I know, what a rat's nest, eh? Okay, so remember in our original motor test, right motor wasn't moving, left motor was moving forward correctly. That's awesome. Okay, now I want to reconnect these, and when I reconnect the power, the Arduino program will start to run, and that should make both motors move forward. These are pretty cheap motors, so not that surprised. Okay, so now I'm going to connect those. Motors aren't running because the controller's not turned on. Just gonna tuck those underneath there. I can always bundle these later on, but I'm still troubleshooting, so I want to make sure everything works. Okay, so I'm gonna turn the motor controller on. Yeah. So this is going backward, and it's not going as fast, even though the motor power is the same. Well, that's a bit of a problem. So I'm gonna have to replace this motor. Okay, well, we're ready to do the fix. I had another motor. I want to make sure that the hookup wires are soldered on correctly. And I got the old one. You see there's quite a bit of hot glue there. But it turns out that if you use a hairdryer, you can soften up the glue quite easily. And now I'm just going to glue the other motor in place. Normally, I would take this out of a video, but I thought the troubleshooting was actually kind of interesting. And that it's important to remind people that, you know, you just got to stick with it. All right, so there's just a little bit of pressure on there to help the hot glue set. And then we're going to go back, put it up on blocks. And then here are the new wires. And I'm going to connect those. Close the garage doors. And then we can connect power again and see how things are working. Try and hide this big bundle of wires here. Power connected to our pigtail. Arduino's on and running. And I'm going to go ahead and, so this is still our test program. Turn the power on. And yeah, so both motors are going forward. That's great. If by any chance one of them was going backward, then I would just take these two wires and switch them. Easy. That's called a hardware fix, as opposed to trying to program it. All right, so that's the end of this part of the video. Now we'll take a look at some more advanced programming. There we go. See, they're both going forward. All right.